So we continue our discussion. From part 1 of this demonstration, we were able to show how to fill up the blue portion of this table, which corresponds to the blue motifs here. Now we try to figure out how to fill this part of the table where you have the orange color. And how you do it is you consider the parts of each unchosen sequence which are not part of the motif. So for instance, for the second sequence here, this is the motif randomly chosen as the motif position, and these are not part of the motif. So we consider these which is not part of the motif. For the third sequence, this is randomly chosen as the motif position, and this part is not part of the motif. For the fourth one, this is the motif position, and this part here and this part at the end are not part of the motif. So for this column here, we consider the parts of the sequences which are not part of the motifs, and we count the occurrences of each of the residues. So for these parts which are not part of the motifs, we count how many A's are there. So for here we count there's one A here, there's another A here, and there's another A here. So that's 3, and we put the 3 here. And then we count the number of C's. There's one C here, there's another C here, and so we have a 2 over there. And then we count the number of G's. We have 2 G's there, and you have a 2 here. And finally we count the number of T's. So there's a T there and there's a T there, and so you have a 2 here. Okay, now once we have the table of counts, the next thing we do is we try to somewhat get the probability of the occurrences of a residue in a given motif position. Remember, these numbers here refer to the motif position. Position 1 in your motif, position 2, position 3, position 4, etc. And so these numbers here represent some kind of probability that a certain residue will occur on that given position. So how do we do this? In its most simplest case, we just sum all of these numbers here. For instance, for the first position, we just sum all of these numbers here, and then we divide each of these numbers here by the sum. But there's a problem here if we do that. So what I'm saying is that you just sum all of the numbers here, and then for each of this position we divide the numbers here by the sum. So that's 0 over 3, 0 over 3, 2 over 3, and 1 over 3. But the problem with that is this would result to probabilities that are 0. And later on you'll see that we don't like that to happen when you have 0 probabilities, because they tend to give 0 probabilities, and that's the end of the story. And we don't like that to happen because sometimes you would expect some kind of deviation from, and sometimes you really don't get 0 probabilities, even though, especially you don't get 0 probabilities even though the probabilities are 0 theoretically. So what we do here is, instead of getting 0 probabilities, we somewhat use a technique here, and we insert what we call pseudo counts. So for each of these residues here, we assign a pseudo count. And so in this case, we assign this bj here is the pseudo count. For each of these residues, we assign a pseudo count of 0.5, but it could have been a different number, like say 1 instead of 0.5. So here the pseudo count for A is 0.5, C 0.5, G 0.5, and T 0.5. So remember, this is just a arbitrary number. It can be any other number. And then the capital B here stands for the sum of all the pseudo counts. So since we assign a pseudo count of 0.5 for each of these residues, and we have 4 of these residues, then 0.5 times 4 will give you 2. So this capital B here is simply 2. So for the first number here, this is 0.1. How did we get this? It's simply 0, which stands for this 0 here, plus the pseudo count from this B over here. The 0 here stands for the count. So we have a 0 plus 0.5, which is the pseudo count, divided by, in this case, 3, since we have 3 unchosen sequences, and we're counting the occurrences of the residues in those three unchosen sequences. So this is simply 3, and then plus 2. The 2 here stands for the sum of the pseudo counts, as explained a while ago. So here we get a 0.1, and which is the number shown here. And then you can do the same thing for the others here. Like for instance, if you have a 1 here, let's try to solve for this one. This one was obtained, this 0.3 was obtained by this 1 here plus 0.2. It's this 0.3 is obtained by 1 plus 0.5 divided by 3 plus 2, and ideally you should get 0.3 there. So it's 1 corresponding to the count of C in the 7th position, plus 0.5 divided by 3 plus 2. It should give you 0.3. Okay, so once you fill up this table here, which corresponds to the frequency counts or the probability that these residues will occur at the given positions in your motif, the next thing is we try to account for the background frequencies, and how you sum this, how you obtain this. In the most simplest case is simply you just divide each of these numbers by the sum of all of the numbers in these sequences. Like for instance, to obtain this number here, it's simply 3 divided by the sum of this one, 2 divided by the sum of these numbers, 2 divided by these numbers here, and 2 divided by the sum of these numbers. But again, we do not like to obtain 0 probabilities because it would mess everything up, and we would always get 0 probabilities all the time, because later on you'll see that the probabilities will be multiplied against each other, and if you have a 0 probability, then if you multiply a non-zero probability by a 0 probability, then it would end up with a 0 probability product, and you don't want that. So in that case, to avoid 0 probabilities, we introduce the pseudo counts. So here we arbitrarily chose a pseudo count of 0.5 for each of these 4 residues, and so this B over here, the small b, is 0.5, and this capital B here is the sum of the pseudo counts for each of the residues. Since you have 4 residues, then 0.5 times 4 will give you 2. And so to get this sum here, this probability here, it's just simply 3, which is this number here, plus the pseudo count for A, which is arbitrarily chosen to be 0.5, divided by 9, which is the sum of all of these. 3 plus 2 will give you 5, plus 2 will give you 7, plus 2 will give you 9, plus the 2 over here, which is the sum of the pseudo counts. So instead of getting 1/3 by simply dividing 3 by the sum of all of these, which is 9, we get something like 0.31 because of the introduction of the pseudo counts. Okay, and then after doing that for letter A, we do the same for we count the we try to obtain the frequency count or the probabilities, the background probabilities for each of the residues, for C, for G, and for T. So for C here, it's simply 2 plus 0.5 divided by 9 plus 2, and it will give you 0.23. And then for G it's similar, and for T it's the same as well.